talk about formulas. We're going to talk about just some basic formulas, and we're going to show them in action and explain how they work, okay? So what is a formula? Well, formula is it's mathematical symbols or variables that express a relationship, okay? So, for example, let's take a look at the formula of the perimeter of a rectangle. Okay, so say we have a rectangle, okay, like so. All right. So we have a side here, and we have a side here, and we have a side here, and we have a side here. Now, if it's a perfect rectangle, right? If this was like 5, and this was 5 inches, this is 3 inches, you could call this the length, and the length would be 5 inches, okay? And you could call this the width, and it would be 3 inches, okay? Well, if it's a perfect rectangle, then this side's also going to be 3 because it's going to equal that side, and this side's also going to be 5. Okay? And then if I wanted to know what the length was around this rectangle, I would do 3 plus 5 plus 3 plus 5. Well, another way of looking at that would be I would take 2 5s and 2 3s and I would plus them all together. So the perimeter, right, would equal 5 plus 5 plus 3 plus 3, okay? Now, 5 plus 5 is 10, right? And couldn't I rewrite 5 plus 5 as 2 times 5? 3 plus 3 is 6. And I could rewrite that as 2 times 3, okay? Now, say I had another rectangle. A better rectangle, isn't it? And say this was 6 inches, and this was 4 inches, okay? Well, perimeter equals 6, and why is it 6 plus 6? Because this side's going to be 6 as well. And then it would be plus 4 plus 4. Oops, too close. There we go. Well, that's going to equal what? 12. That's going to equal 8. You could rewrite that as well as 2 times 6 and 2 times 4. All right, now, what has changed between these two rectangles, right? They're basically the same shape, right? But the size has changed. The scale of that rectangle has changed. It's now the length is 1 inch longer, and the width is 1 inch longer. Okay? But what didn't change? What hasn't changed? Well, what hasn't changed is the fact that in order to get the perimeter, you have to plus this side by this side by this side by this side. Another thing that hasn't changed is the shape. Another thing that hasn't changed is that there's 4 sides, and this side is equal to that side, and that side is equal to that side. So we can see a pattern here, and the pattern is this. Perimeter of a rectangle is equal to 2 times its length, right? Let's say that's the length, and this is the width. 2 times its length plus 2 times its width. And that holds true for this one over here. 2 times its length 2 times its width. Okay? And then we can, instead of saying perimeter, writing that out, we could just do P. So P equals 2 times length plus 2 times width. Okay? Now, what we would call this right here, and this right here, and this right here are variables. They vary, they change. And we can see that is true. This changed from a 5 to a 6. What else changed? I didn't look at it. I didn't identify it, but let's identify it now. That perimeter changed. That perimeter is a 16 here, because 10 plus 6 equals 16. And the perimeter over here, this one, right, is going to be 12 plus 8, which equals 20. So this changed into 20. 20 equals 12 plus 8. 16 equals 10 plus 6. All right? And so the perimeter changes based off of the length and width, the measurements of the length and width. Okay? So this perimeter is another thing you could say this perimeter is the output of 2 times length plus 2 times width. And this, the length and the width, could be called the input, okay? And each one of these letters is called a variable because they vary, they change. They're not static, they're not constant. But what is constant? What always is the same in this equation? Well, the 2 is, because there's 2 sides for a length and there's 2 sides for a width. And that always is the same. It's always going to be the same, okay? So this would be the formula for the perimeter of a rectangle, okay? So let's look at the formula of the perimeter for a square. All right, so say we have a square right here. It's not a perfect square, but it doesn't look like it's perfect, but we'll just pretend it is. So let's say that it was 4 inches. We know the side, okay? Well, if we know the side, just one side, okay, of a square, if it's a perfect square, we know by definition that a square has equal sides. Every side's equal. Well, if that's the case, then we know this is a 4, and that's a 4, and that's a 4. Okay? And we just call the side because it's not length and width. Length and width indicates that there's a difference. There's not a difference. They're all the same, so it's just a side. Okay? So the perimeter of this is equal to 4 plus 4 plus 4 plus 4. Okay? Which equals what? 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. Right? Okay. And that could also be rewritten as what? Well, that could be written as 4 times 4. Okay? 4 times 4. All right? And that, therefore, can be rewritten as this. 16 equals 4 times 4. Or 16 equals 4 plus 4 plus 4 plus 4. Okay? So what does this 4 represent? It represents the s. And let's look at another one. Let's look at another one. Let's go here. And let's say we have a square that has a 5. Okay. So we have a 5. Well, we know it's a square. It's 5 inches, right? That's what one side. Well, we know that all of them have a side of 5. All right. Well, then perimeter equals 5 plus 5 plus 5 plus 5. Okay. Well, that's going to equal what? 20. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So the perimeter is 20. And 20 equals 5 plus 5 plus 5. Or you could rewrite 5 plus 5 plus 5 as 4 times 5. Okay. So what changed? Well, let's look at that. Let's look at that. Let's look at what stayed the same first. Well, there's 4 sides. That's all the same. Okay, on both of the squares. But the length of each side of the square changed. This is 4 inches, and these are all 4 inches, and this is 5 inches. Okay, so that changed. So the size of the square changed. Okay, and if the size of the square changed based off of the length, right, then the perimeter changes. So 16, and this is 20. Okay, so the side changes, the length of the side changes, and the perimeter changes. Okay, but what doesn't change? Well, the fact that there's 4 sides. Okay, so because that doesn't change, you could rewrite this as P stands for perimeter equals 4. That doesn't change, but sides does. The length of the side can change. So P equals 4s, or 4 times s. All right? Okay. So let's look at the area. Let's talk about the area of a rectangle and a square. All right. I hope you're getting this. Let's try this. So let's say we have a rectangle. Let's say that we have a length of 5 here and 2 here. Okay. Well, let's use something a little bit. No, that's fine. Length of that. All right. So that means that this is inches and this is inches. And that means that we have to divide this into 5 inches. Okay. So 1 inch, 2 inch, 3 inch, 1, 2, 3, 4, 5. And then this is 2, so this has to be divided in half like that. So then we can count those up. This area is how many inches are, or if this was feet, how many feet are inside of this rectangle. Well, in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so area is equal to 10. Okay, that's the area. Well, that's just counting it, but wouldn't there be an easier way? Well, how about this? 5 times 2. 5 times 2 equals 10. So you could do 5 times 2. And 5 is the length, and 2 is the width. All right, let's see if that applies. Let's see if we can do the same thing to another one. Let's do 3 and 2. So let's divide that into three things right there. And these are inches again. So what's the area if it's 3 inches by 2 inches? Well, 1, 2, 3, 4, 5, 6. Well, that's also equal to 2 times 3. So it does work. So area equals 6. which is also 2 times 3. All right, and then we could rewrite that as area equals 2 times 3, and 6 equals 2 times 3. Okay. So in this case, everything's changing. There is no constant, all right? So we would do A equals length times width, all right? I guess you could say there is a constant. There's a one side here and a one side here, so you could have a 1 here and a 1 here, but it's still going to be the same. Area equals 1 length times 1 width, okay? Anything times 1 equals itself, so we don't really need to take in consideration the 1. But if you want to, you can, but it's not necessary. So again, the formula for the area of a rectangle is area A equals length times width. You could rewrite that as just LW. Okay? All right, so let's look at the area of a square. All right, so square. That was a square. Let's do a 5 here. A 5, and if it's a real square, then all the sides are gonna be 5. Okay. And let's do another one over here. Let's do 2 and 2. Well, if it's 2 and 2, it has to be divided like this. Right? It's 2 inches. 2, 1, 2, 3, 4. All right. So, and then this one has to be divided into 5. And 5 again. All right. So, to find the area, just like with the rectangle, we need to know how many inches are in this square. We just count them up. We go 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And over here we have 1, 2, 3, 4. All right, so this is 4, and this is 25. All right. Okay. Well, that could be rewritten as well as 5 times 5, and this could be 2 times 2. Then 5 times 5 equals 25. 2 times 2 equals 4. So the area changed from 25 to 4 based off of the length of the side of the square. Okay. Now, what's another way we could look at this real quick before we erase it? This could also be, instead of 5 times 5, can that be 5 squared? And can this be 2 squared? 2 squared equals 4. 5 squared equals 25. Yes, it could. So, again, this is a side, and this is a side. And this is a side, that's a side, that's a side. All right. And so we could rewrite that we could write that as a formula, such as using variables such as these. So A could be replaced as area could be replaced as A, and this 5, which is a side, could be replaced as S, and then squared. All right. And this is also could be a equals s squared. All right, the s is going to change. That's a variable that changes, it varies. See, that's a 2, and that's a 5. And the area changes. That's a 4, and that's a 25. But here, the 2 doesn't change because it's 5 times 5, or 5 squared, and 2 times 2, or 2 squared, okay? And so if you have another square, okay, and you're using the same formula, say another square such as 7 times 7, I mean a square that had 7 sides, I mean a side was 7 inches, then all you're going to do based off of the area is you're going to do a equals 7 squared. So the area would equal 49. Okay? All right, that's pretty much it for the formulas and how they apply to shapes. And basically what a formula is, like we said before, is it's a mathematical group of symbols, okay, or a mathematical expression that expresses a relationship, okay? So this S right here, all right, that's a symbol, okay? And this A is a symbol, and they express a relationship, and the relationship is this, that whatever you put over here, you square it, and it will give you the area, okay? And that holds true. If we put a 7 into the S, substitute it, and we square it, then A is equal to 49. And that's worked the same with the perimeter for the rectangle and for the square as well. So just remember that when you have a formula, what you're doing is you're going to be looking for the values that are needed to substitute into the variable. And the variables are called variables because they change. Okay? All right.